Our next part is melting. As we have already studied about melting, the change from solid state to liquid state on heating at a fixed temperature is called melting. And what is melting point? The melting point is the temperature at which solid changes into liquid without further increase in temperature is called melting point of a solid. For example, the melting point of ice is 0 degree Celsius. That is, ice start getting melted at from 0 degrees Celsius to form water, which is liquid. Our next part is vaporization. Our next part is fusion or freezing. In this part we will study about fusion and fusion point. The change from liquid state to solid state on cooling at a fixed temperature is called fusion. Example, water to ice. And the temperature at which liquid changes into solid without further decrease of temperature. In this we have to understand that it is without further decrease of temperature because liquid changes into solid. In temperature is called freezing or fusion of a liquid. For example, liquid which is at, for example, if we take example of water, it freezes at 0 degrees Celsius. That is, its water start getting freezed at 0 degrees Celsius from liquid and to form ice, that is solid. This is called freezing point of any substance. Now here in this chart you can see that they have mentioned the melting point of few substances like ice, wax, naphthalene and copper. You can see the ice, the melting point start at 0 degree Celsius by absorbing the heat, which is mentioned here in joules per kg. This is the SI unit of heat. Next substance is wax, which is getting melted at 55 degrees Celsius by absorbing the heat 147 into 10 to the power minus 10 to the power 3 joules per kg. Our next substance is naphthalene, which is getting melted at 80 degrees Celsius by absorbing heat of 147 into 10 to the power 3 joules per kg. And the next one is copper, which is getting melted at 1085 degrees Celsius by absorbing 1806 into 10 to the power 3 joules per kg of heat. In this process, heat is being absorbed. Our next part is explanation of melting by molecular model. Molecular model is the arrangement of solid in a matter. In a solid, the molecules are closely packed. We have already studied this, that is, they have a less intermolecular space, and therefore, because they have a less intermolecular space, so the intermolecular force of attraction is very strong. The molecules only vibrate about their mean position, so they have a small kinetic energy, because we have already studied this part in this chapter, that the molecules of solid vibrate at their mean position. They do not leave the solid. They have a large molecular force of attraction amongst them. Why? Because they have a very less intermolecular space. On heating solid, the kinetic energy of molecules increases, due to which they begin to vibrate more violently. For example, if we heat ice, what happens? The ice will change into water by absorbing heat, and the molecules of water will start vibrating violently at a particular temperature, which is called melting point of that material, and the molecule acquires sufficient kinetic energy to become far separated from each other by overcoming the force of attraction. They become free to move within the substance, that is, the state of substance becomes liquid. In this state of heat energy absorbed by the substance does not change the temperature of the substance, but it utilizes in doing work against the force of attraction in increasing the separation between the molecules. Once the molecules absorb the energy and gets changed into liquid, it does work against the force of attraction. This is what is being explained in this paragraph. Our next process is vaporization and vaporization point, or you can say boiling point. The change from liquid state to gases, the change from liquid to gaseous state, or you can say vapor state on heating at a constant temperature is called vaporization or boiling, and the temperature at which liquid changes into vapors without further increase in temperature is called the boiling point of that liquid. For example, the boiling point of water is 100 degrees Celsius, at which it starts getting boiled and changes into steam or gas. In this activity, it has been explained, which you have to read by yourself. Our next process is condensation. The change from the vapor state to liquid state at a constant temperature or on rejecting heat, and this is the reverse of vaporization. On rejecting heat or on cooling is called condensation. The temperature at which the vapor changes into liquid without further decrease in temperature is called condensation point of the vapor. For example, steam, or you can say gas or vapors at 100 degrees Celsius condenses to water, or water droplets at 100 degrees Celsius on being cooled. As I have already told you to take example of hot glass of water and cover it with lid. After few minutes, when you uncover that glass of water, you will see droplets of water on that lid. This is the example of condensation, and condensation we can see in the nature by example of water cycle. We will continue our next part in our next class, that is explanation of vaporization and vaporization on the basis of molecular model and evaporation. Thank you, class.